This video is to describe a feature called AWS Split Cost Allocation Data and to discuss some details about what the feature is and some problems with its usage. Before we get into it, let's step back and see why this feature was actually created. AWS has basically two fundamental ways in which you can run containers on their infrastructure. One is using a homegrown custom AWS custom orchestrator called ECS. So it's basically Elastic Container Service. And then the other is based on an industry standard called Kubernetes, so Elastic Kubernetes Service. Both of these can actually run in either a serverless model, which is called Fargate, or based on virtual servers, which is EC2, right? So you can have EKS on EC2, ECS on EC2, EKS using Fargate, and similarly ECS using Fargate. Now, diving into a little bit of details about those two options, basically serverless option as well as the server-based option on the left. The serverless option, the customer is charged just for running the container itself, right? So they don't own any infrastructure. They're just charged for the actual running of the container task. So in this case, there are 6 tasks, and you will see in your cost and usage report costs for each of these running of these tasks. Whereas in the server-based models using ECS on EC2, you effectively own the underlying EC2 instance on which the task is running. So you're not charged for the actual tasks, but you're charged for the container, right? For the container instance, which is basically the EC2 instance. So in the cost and usage report, you'll see line items for EC2. So this is a problem because, if you wanted to understand the costs of particular containers, you didn't have that visibility. You just had the visibility of costs at the EC2 level. So this is why AWS Split Cost Allocation Data was invented, to break down the costs of the EC2 server into the underlying, into the container cost that it's running. So just to back up and sort of give a brief primer on containers itself. So applications have really 2 fundamental ways in which they're architected. On the left here is the monolithic way. And here, basically, let's assume you have a photo editor app, a simple app. You have a mobile app where the users can log in, upload their pictures from the mobile device, and they go into the cloud, and the pictures, you can add effects on those pictures. After adding the effects, you can store them in some Amazon S3 storage, let's say. This app itself is running on Amazon EC2 instances, and maybe there's some information about the users who are logging in this database instance, right? So this is called a monolithic architecture because there's just one big application that's running, and it's using all these various AWS resources, right? On the right here, though, you see a more complicated architecture, and let's say this is for Netflix, famously uses microservices. So the user logs in either through the web app or through the mobile app, or an app on your device, TV device, and all of that, all those interactions go through this API gateway, just as in the left-hand side. But then you see that there's no big monolithic app. Instead, there is a multitude of these microservices. So, for example, to log in a user, there may be an authentication service, right? And then if you're searching for videos, there could be a search microservice, right? And similarly, if you're signing up for Netflix, the order service, something like that. So there's multiple microservices that all communicate with each other, but also have their own storage, as well as they can scale independently. So if lots of people are doing searches, this number of instances of the search service will multiply, right? You can spin up more instances of the search service. Typically all these microservices run on containers. So this is the intersect between, so the microservices architecture really brings about the need for containers, right? All of these are run in containers, right? So obviously, when the architecture is complex and has many parts, it's better to do something like a microservice architecture. So this picture shows the same thing that we saw before. On the right hand side is the Fargate, which is a serverless model, and the Netflix microservices are just running as tasks, right? So in this case, there are two authentication services, three search services, one order service. So you can scale as many each of them as you like, right? So the search service might decide, there's a lot of people searching, I need to spin up more. So that's kind of how it works, right? On the left hand side, though, this is where the microservices are running on the EC2 instance. So I have two in EC2s. And the first one is running one auth service and one search service, and the second one is running two search containers, one auth container and one order container, right? So this, if you see, the end result is the same, but except that, in this case, for example, a lot of the compute capacity of this first EC2 instance is left unused, but you're still paying for the EC2, but you're basically not using it, right, to run containers. This picture just shows a little bit more detail, right? So it shows that the auth service is talking to the auth database or whatever it has. And similarly, the search service, which is all the green containers, are all talking to their storage, and you can see that they're all tagged, right? All the blue services are tagged with this microservice auth, so they have cost allocation tags on them. Both the container as well as the storage are tagged, right? So the red stuff is also tagged. The red container, which is microservice order, is tagged, and similarly, the database is tagged as well. And on the left side, the same thing, right? We've tagged everything. But remember that we are basically running the containers on EC2 instances. So the EC2 instances themselves can be tagged, right? In this case, I've tagged both these EC2 instances as microservice not container, right? Because they're not containers. There's just EC2 instances. So I've just put a tag on both those EC2 instances saying microservice not container. Okay. Now, as I said before, there's some unused costs in this first EC2 instance. And then the second thing is both these EC2 instances are doing a lot of other things besides just running containers, right? There could be some data transfers coming from outside or going outside, or they could be reaching out to the disk, all of that, and you will see charges for all of that, right? So it's not just container costs, but costs for running the containers, but it's also other costs that are associated with the EC2. Right. Additionally, this, as we said, all these storage costs, you will see those as well, but those cannot be split up, right? You might want to split the EC2 costs into this container costs, but for example, this EC2 cost will be split up into auth service costs and search service costs, whereas this one will be split up in 4 ways. But these storages will remain unsplit because they don't need to be split up, right? They have the right tag on them, right? So ideally, what do we want to do, right? This is the same picture as before. This first EC2 is corresponding to this EC2 on the left here, right? So it's running auth and search. And so you'll see here, this EC2 is performing a run instance operation and running the auth and search containers. But it's, like I said, it's also running other operations, right? Like doing data transfers, etc., right? And those are not split up. And then obviously we have the databases, so it's showing the two database costs. Now, what are the two objectives that we're trying to do? We're trying to figure out, as we said in the previous picture, we're trying to figure out, we don't want the cost of the EC2, we want the cost of the auth service and the search service, right? So how do we compute the cost of the auth service? In this case, it'll be the auth service uses its RDS instance, so it'll be this $10 plus the $30 associated with running the container. But while running the container, there's certain unused costs as well, which is like $17. So really, the cost of running this auth service is $10 plus this $13, which is $23, right? Similarly, the cost of running the search microservice is 20 plus $15, which is $35, right? That's what this shows here. And all the other costs are basically unallocated. So the costs that are corresponding to the data transfer or the unused costs, all of these are unallocated to the container. They're not associated with the containers. So the unallocated cost will be 18 plus 17 plus 37, and that's about $72, right? So this is kind of what we want to do. We want to say, hey, what's the cost of this auth service, what's the cost of the search service, and what's left unallocated, and maybe I'll take the unallocated costs and just spread them across, do 50-50 across auth search, or maybe I'll allocate it to the IT department. I'll do something with those unallocated costs, but I need to figure out the cost of the containers. So the objective number one is to figure out what is the cost of each of these containers. Container, basically application, the cost of the microservice is what I'm trying to figure out. And then we also want to figure out what are all the costs that are left unallocated after the microservice, and that we need to somehow allocate using some other tools like cost categories, right? So then let's look at this by looking at a curve snippet, right? So if you did not enable split cost allocation data, you will just have these three lines, the first three lines in the curve. So it shows RDS costs. It shows this 1, 2, 3, 4, 5 is the resource ID of that EC2 that we're using. So the EC2 is doing some data transfers, $3.20 for that. RDS is 20 cents. And these numbers are just made up numbers. So just for the purposes of this exercise. And then the actual costs of running the containers, if you didn't have split cost allocation data, it'll be just shown as the EC2 cost, which is $1.50 in unblended format. And in savings plan effective format, it's $1, right? So these are the only three lines you will have. And obviously, because the EC2 itself has been tagged as microservice not container, you will see that there's a tag of not container on these line items. But the RDS instance here, we did tag it as microservice auth, so you'll see that tag as well here, okay? Now, if we did enable split cost allocation data, basically what it does is it takes that run instance line items for these EC2 instances and splits that out, right, according to the containers that it's running. So in this case, it's splitting it out, as you can see, into multiple line items. And based on which container it's running, the tags are also there. So this is the whole purpose, right, to figure out what is the cost of the microservice. So like we said, the first objective is to find out the cost of each microservice. So if we didn't have split cost allocation data, we won't have all these line items. And if you said, okay, what's the cost of auth microservice, you would just see one line item, which will be like 20 cents. But that's not true, obviously, because it's some of the cost of the EC2 should be attributed to it. So then now with this split, theoretically, we should be able to figure out what's the cost of the auth microservice. But can we do that, right? So now that we've tagged it, let's see if we can do it. Really, it becomes complicated because, as you can see, these line items that have been generated don't have any costs. In this unblended column, it's all empty, right? Instead, AWS split cost allocation data creates these new columns, new type of costs. Okay, basically, these are amortized costs. It generates two types of costs, amortized and net amortized costs, whereas the original costs don't have amortized and net amortized cost types at all, right? So, so if you look at the objective of what is the cost of the auth microservice, that is difficult to compute because if I use the unblended cost format, I don't have it for the containers. And if I use the amortized cost, I don't have it for the original original costs, right? So either way, I'm not able to aggregate these costs and figure out what the cost of, like aggregate the RDS cost with the cost of these containers to tell you what the auth microservice cost is. So that's problem number one. Then, as we said before, we wanted to figure out what the cost of each of these microservices are. And then secondly, we wanted to figure out what is the unallocated costs. So now how do we look at unallocated costs? So if we didn't have, again, let's look at it as we didn't have split cost allocation data, we won't have any of this. Okay, so then if you look at the tag not container, it'll add up. If you're looking at unblended costs, it'll add these two up. So it'll say 470 is the cost of that EC2, basically, right? Or in unblended format. But if you or you can look at blended format, or AWS also publishes a script by which a SQL query by which you can figure out what those costs are in amortized format as well. So although Kerr doesn't have it, you can pull it from Cost Explorer, the amortized cost format. So that's how you would figure out what is this cost of the EC2. But now with the split cost allocation data enabled, what is the cost of that EC2 instance, which is like basically unallocated? It should not be $3 $3.20 plus $1.50, because a large portion of the $1.50 has been or $1 in savings client effective cost has been split up, right, into the containers. So it does not make, so you somehow have to extract from this not container cost, from these costs, from these two line items, we have to extract this cost out. So how do we do that? Again, we have the same problem of, cost types being different, but let's say somehow we are able to figure out, convert these into amortized costs, and then we're able to extract this. But that extraction becomes complicated because you can't simply extract out the entire $1.50, right? Because there is a bunch of unused costs as well, right? So that needs to be added back. So this is the complexity. How do I figure out the unallocated costs on that EC2 instance, which are not associated with any containers, that should then be allocated to something else, right? That is difficult to figure out in this approach of representing costs. These are some of the challenges. Basically, how do I use tags? The problem can be summarized as, how do we use tags to determine the cost of the microservices? And after determining the cost of the microservices, how do we determine what are the unallocated costs, right? Because there's some unused costs here. There are costs that are not been split up, like this data transfer costs here. So we need to aggregate all of that, and that is difficult to do with this representation. So that was a summary of the challenges with using AWS split cost allocation data. If AWS was to actually represent, provide a query on how to do this, right? How do we extract this information that we need? How do we use tags on this information that's generated? That'll be very useful. And the other thing is, when you enable split cost allocation data, effectively all your EC2 instances are going to get split up, right? But you cannot, perhaps you don't need to split some other EC2 instance. I mean, you only want to split this one instance. You don't want to split this other instance. That cannot be done. That granularity of saying, I want to split only instances with this tag cannot be done with this approach, and that results in really a big blow up of the curve, which is already quite big. So that's all, and that's a summary of all the problems with this feature. Thank you.